Amazon and Microsoft might seem to rule the cloud, but that doesn't mean they're your only options. There are a lot of smaller cloud providers out there that don't have the same marketing budgets as these multi-billion-dollar monsters. The question is, which one's best for you? Welcome back to the Pro Tech Show, the place for tech tips and advice for IT pros and decision makers. The inspiration for this video came from a comment by Harry Truman, who asked, how about a video on an alternative to AWS, Azure and Google Cloud, assuming there is an alternative. He goes on to mention Linode as one possible alternative he has heard of. I thought this was an interesting question. The smaller guys have to offer something more than what the likes of Amazon and Microsoft are doing just to survive. But they simply don't have the resources to go head to head with them on all fronts. What this means is that you need to consider your specific requirements before making a decision. This video will help you think about the questions to ask as well as help answer some of those questions, but the conclusion for you will be different from the conclusion for someone else, and that's okay. Stick around and we'll take a look at the features, costs, including the unexpected ones that can catch you out, reliability and some general use cases. There are loads of companies selling cloud services, so to make this comparison easier, I'm going to group them into 3 categories. I will mention some vendor names for illustration purposes, but the comparisons I'm making are between categories of vendor rather than individual vendors. I haven't got time to compare every single supplier properly in this video, so I'm going to keep it more general. First up, you've got the big guys, Amazon, Microsoft and Google. You pretty much know what you're getting here, largely speaking anything you want, and they're priced relatively similarly to each other. Then you've got the little guys. This part of the cloud is a bit of a wild west. This is where you'll find your local service providers and a number of data centers that are trying to convert empty rack space into cloud revenue. In this category, you have the ability to get a much more bespoke service than the big players are capable of offering. SLAs to match your precise needs, custom terms and conditions, bespoke combination of your services and theirs meshed together. It's all possible when you work with a small provider who doesn't just see you as a number and won't try to force a one-size-fits-all service down your throat. There are some really great providers here, but unfortunately there are also a lot of incompetent cowboys who think they can run a cloud service just because they figured out how to reboot a server once. The nature of this space is that providers tend to be localized, meaning you probably won't have heard of the ones I have, and I won't have heard of the ones that you've heard of, so I can't really name any in this video. Their customers are likely to be localized around a small number of data centers as well, so there's a good chance you can actually find some and speak to them. That's probably the best advice I can give you here. Check the service level agreements, check the certifications, but get some good old word of mouth experience to figure out if a particular vendor is one of the good ones. For the purpose of this video, I'm going to ignore this small provider category. That doesn't mean you shouldn't use them if you find a good one, it just means that I can't practically cover them in any useful depth in this video. Obviously though, I've left quite a gap between the really big vendors and the really little ones. This is where the other vendors live, the ones that are providing public cloud services that compete more directly with the big guys, but without their massive budgets and established market dominance. Examples of these are Linode and DigitalOcean. Maybe Vultr too, although their services are a little bit more limited. These guys can't touch Amazon, Microsoft or Google when it comes to breadth of services, not even remotely close. The big players offer so many different services that navigating them is a skill in itself. In fact, there are plenty of people who make a pretty good living out of knowing the difference between them all and when to use each. So while AWS has what appears to be a limitless array of services for whatever you might want to do, the flip side to that is a smaller provider like Linode with their more limited offerings is a lot easier to understand. For smaller businesses that don't have a partner to help them, that could be an actual benefit. For example, if you want to deploy a database on Linode or Vultr, you'd deploy a server running a database. DigitalOcean have a managed database service you can deploy instead that abstracts away the server. They even have 3 types. Cool, right? AWS has 14 types of managed database service. And even that doesn't tell the full story because 2 of DigitalOcean's only make up 2/5 of one of Amazon's. These middle tier providers provide the basic bread and butter services of the public cloud, namely servers and storage and maybe some containerization support. I have to apologise for the rest of the video because I'm probably going to keep calling these guys the little guys. That's not really fair, they're not little. It's just that compared to Amazon, Microsoft and Google, everyone's little. And I'm excluding the actually little guys, it's all relative. In terms of differences between the 3 I mentioned, Vultr seems to be a bit behind the other 2 in terms of both scale and breadth of services. The Node is only one of the three to offer cloud-based GPUs, and DigitalOcean seems to be a bit more mature in terms of their platform diversity and are dipping their toe a bit further into the serverless space with the aforementioned database service, as well as their app platform. As impressive as all of this may sound, it barely scratches at what Microsoft, Amazon and Google offer, particularly when it comes to serverless platforms, artificial intelligence, media, security, scalability, automation, monitoring and integrations. The big guys just have a lot more resources to build and innovate on this stuff. They're always going to have it first because they're the ones coming up with a lot of the new ideas. One thing for you to think about here is what services you actually need. If you just need a server, then take your pick. Everyone has them. If you want packaged AI services like machine learning and natural language processing that's ready to use out of the box, then that's something that's really going to immediately push you towards the big guys. Even if you just want a server, although I said everyone has them, that's not quite true. They all offer servers, yes, but which servers? If you want a standard run-of-the-mill server, then you're fine. But if you need something special, that might push you towards the big leagues. For example, the biggest virtual server Vultr have listed on their website comes with 96 GB of RAM. That's quite a bit. But Amazon will let you go up to 24 TB. And what about the operating system? All of them feature a nice selection of Linux distributions, but neither Linode or DigitalOcean supports Windows. Keyword support. I know some people have managed to get to work with a kludge, but you really don't want to run your business on an unsupported kludge that might stop working when the vendor performs a platform update. If you're building a cloud app on Linux, then who cares? But most businesses I've come across run the majority of their productivity services on Windows, and this is a major limitation. Presumably it's for cost reasons, because they also don't offer paid Linux distributions like Red Hat and SUSE, which is going to limit their appeal to a lot of enterprises. It's a similar story when it comes to data centers. All of the vendors I've mentioned have data centers dotted all over the globe. The big guys just have more of them, in more locations. You'll also tend to find that the smaller guys are renting space in other people's data centers, whereas the big guys are often building their own dedicated facilities, sometimes at the bottom of the sea in Microsoft's case. In theory, this means the big guys have greater scope for scalability because they're not competing with other customers of those data centers, but that hasn't stopped them having occasional capacity issues. Another benefit of the bigger players is their integrations with other systems, particularly hybrid cloud topologies. All of the vendors I've mentioned provide cloud storage, sure. If you use a Windows file server though, you can automatically offload infrequently accessed data up to Azure, it's just built in. If you have a legacy backup system, you can deploy an appliance that will pretend to be a tape drive and actually connect to AWS. So your backup system that doesn't know anything about the cloud can run a backup to tape and actually be sending offsite backups up to AWS for long-term archival and Glacier storage. So if the big providers do everything the smaller guys do, but at a bigger scale, with more options, and they offer a ton more services besides that, why bother with the smaller ones? Clearly they must have found some way to compete or they wouldn't still be around. So what do you do when your services are less mature and less comprehensive? You have to provide better value, and that's exactly what they're doing. Now you do need to pay attention to the comparisons here because there are so many options it is easy to get bamboozled. Also please note that the prices are correct at the time of recording, but this is the cloud so they will change. Treat them as indicative. Where data center choice affects price, I've used whatever default option was presented by the vendor. Let's compare prices for a fairly basic server spec, 2 virtual CPUs, 4GB of RAM and an 80GB SSD. To make it a fair comparison, I'm going to exclude ARM processors and make them all standard x86. I've chosen this specification because all 3 medium tier providers I mentioned have an option here and they all cost $20 per month. The cheapest on AWS is a T3A Medium EC2 instance that comes in at $35.45 per month. That's already more expensive, but there's more bad news for Amazon because those T machines are what's known as burstable. That means you don't actually get the full CPU listed on the spec. The deal is that they expect the CPU to do very little work a lot of the time. Whilst it's idling, you build up credits that you consume every time the CPU ramps up. It's a way to save money in your cloud costs if you only occasionally need its full processing power. The cheapest option that actually gives you the full processor is the A1 Large option, which pushes the price up to $45.23. Except that's now unfair in the opposite direction because the $20 options from the smaller providers don't quite give you the full CPU either. They're what's known as shared instances. You're not limited to occasional bursts, but the virtual CPUs are over-provisioned, meaning the actual physical CPUs are shared between multiple virtual CPUs. Normally this is fine and you won't notice, but if multiple servers ramp up at the same time, they may end up competing for the same resources and incur a performance impact. This is the potential for your performance to decrease because of another noisy customer on the same platform. To make this more comparable, we'd need to upgrade to dedicated CPUs. DigitalOcean and Vultr don't have options at this low price range, but Linode do, and it takes the cost up to $30 per month. This is still a fair bit lower than AWS, but Amazon do have a few more tricks up their sleeve. Before we get to that, let's try and put everyone back on an even-ish footing, because at this price point DigitalOcean and Vultr are stuck with shared CPUs, which puts them at a performance disadvantage compared to AWS and Linode. At $60 per month, everyone gets dedicated CPU options. DigitalOcean gets you 2 virtual CPUs, 8 gigs of RAM and an 80GB SSD. Linode gets you double the CPUs at the same price, whereas Vultr gives you more storage and twice the bandwidth instead. Amazon can more or less match any specification you want, so I'll use Linode's for comparison purposes. Amazon's cheapest option is A1 Extra Large, which is $82.46 per month, 36% higher than Linode. Or is it? Welcome, my friends, to the confusing world of cloud cost optimization. For some reason there aren't actually any burstable options that are cheaper than this, but there are other ways we can reduce the price in AWS. If you know we're going to need the server on a permanent basis, we can reserve it for a full year. This locks us in and removes some of the cloud flexibility, but it drops the monthly price to $54.94, which is just cheaper than Linode. If we're willing to both commit to the full year and pay the entire year up front, it drops to $43.75 per month. If you're in this for the long haul and have the cash burning a hole in your pocket, you can even reserve and pay upfront for a full 3 years. This costs $1,008 upfront, which is the equivalent of $28 per month. A cheaper option still is to use spot instances. There is no upfront cost or commitment for this, and it drops the price to around $22.15 per month. With a very significant catch though. Firstly, the price will fluctuate. More importantly, there is no guaranteed availability. Spot instances run in Amazon or Azure's spare capacity. From their perspective, it's more cost effective for them to sell the spare capacity on at a huge discount than leave it empty. The actual price depends on how much spare capacity there is. If utilization goes up, so does your price. If a customer comes along and wants to use the infrastructure, then it's no longer spare and they'll just turn off your server and give it over to the paying customer. That's quite a catch, and not appropriate for a service that is in any way business or time critical. If you need to do some number crunching though and you don't actually care when it gets done, then spot instances can be a good way to keep the price down. It's not really a fair comparison to Linode though, because of the fact your server might just get shut down. If we switch back to our best case scenario for AWS, it's a 3-year upfront payment. So is that it? Pay upfront and the big players are cheaper? No, I have thus far left out one very important cost: data transfer. As a general rule, cloud providers allow you to transfer data in for free and they charge you for outbound transfer. You might also get charged for data transfer between different data centers belonging to the same provider. Why charge for data out and not data in? A cynical person might point out that it makes it relatively affordable to move your data into the cloud, but expensive if you ever try to leave. The important thing that's missing from these calculations is that the Amazon server included 1 GB of data transfer. Beyond that, you need to pay for more. Linode by comparison included 5 TB. This is quite a lot of monthly data transfer. For many use cases, it's way more than you'll actually need, although I have recently built a server that burnt through that in less than a week, so it's not ridiculous that you might need or exceed it. If I had 5 TB of monthly outbound data transfer to the $28 3-year reserved AWS server to make a like-for-like comparison with Linode, the monthly cost skyrockets to $496.71. This is where people often get bitten by unexpected costs in the cloud. The big providers all seem to price themselves using the same model as budget airlines. The base price is pretty reasonable, but they get you with the optional extras that aren't often really that optional. This is where you need to consider your own scenario. If this AWS server was something like a domain controller that is only ever going to be internal, then outbound data transfer isn't an issue and you can optimize the price quite nicely by using reserved capacity. If on the other hand you were building yourself a personal Nextcloud instance, the file synchronizations in that server could kill you and quickly rack up an eye-watering bill. It's not just AWS. Up in Azure, from the included 5 GB of transfer to 5 TB adds an extra $255.75 per month just for that bandwidth, and they also charge for storage activity as well as capacity. Where you definitely won't find any unexpected costs is on this channel when you like and subscribe, because it's always free and you'll never want to leave. Okay, I've probably assaulted you with enough pricing comparisons for now, so let's move on to reliability and the different service level agreements. On the face of it, they all offer 99.99% uptime, with the exception of Vultr, which apparently offers 100% uptime. But it's really not that simple. Let's take the big players first. They're very much aimed at the enterprise use case. The 99.99% SLA only applies if you take steps to protect the uptime of your servers by making them highly available. It's really an SLA for your applications running on them rather than the server itself. These enterprise clouds are split into multiple zones, and the promise is that they won't have simultaneous outages of multiple zones. So if you build out your cloud infrastructure so an application is spread across multiple servers in different zones, then there's an agreement that the application as a whole will remain up for at least 99.99% of the time. It is not a promise that every individual server will remain up 99.99% of the time. If you deploy a server as a standalone instance, then your SLA is much lower. With Google, it's 99.5%. With Azure, it's somewhere between 95% and 99.9% depending on which storage tier you chose. With Amazon, it's a mere 90%. This is something a lot of people miss. They see 99.99% and don't realise that because none of the servers are clustered, they only get a fraction of that guarantee. Another way to look at it is the effort Amazon, Microsoft and Google put into protecting your uptime is proportional to the effort you put in. Unfortunately though, this does mean more than doubling the costs you may have planned in order to scale out and add load balancing if you do want to get those uptime guarantees. Now, interestingly, these limitations don't apply to the smaller providers, most likely because a lot of their customers aren't big enterprises, so this just wouldn't fly as easily for them. They do have their own loopholes though. Vultr and Linode both have exceptions that allow them to have service disruption as long as they give you sufficient notice, and this doesn't count towards their SLA. If you're wondering how Vultr can promise 100% uptime, well then Linode only start the clock for unplanned downtime, not planned downtime. I couldn't actually find a similar statement in DigitalOcean's SLA, which seems to imply they do offer 99.99% without any catches. Let me know in the comments about that one if I missed something, because it surprised me, because just from a bit of random googling they seem to be the one with a higher number of complaints about outages. That might just be because they're bigger than Linode and Vultr, so there are more people to complain. This is all completely anecdotal, I don't have any statistics, but please let me know your experience in the comments down below. It kind of goes to show that the SLA isn't everything. It's important as a guide to know what a reasonable expectation of the service should be, but usually the penalty is you get a bit of service credit if the SLA is breached, which for some of the options we've looked at could actually be less than $1. So when should you consider one provider over another? Well, in an objective sense, if we exclude price, then the bigger providers are better than the medium ones. They have more services and greater scalability. But if your use case fits within the capabilities of the mid-tier providers, then you could potentially save a good bit of money, particularly if you plan to use a chunk of bandwidth or simply want to avoid too many surprises in your bill as a result of it. That said, the serverless computing options provided by the larger vendors may offer opportunities to reduce your costs beyond what you can get with virtual machines, even cheap virtual machines. Link up here and in the description for that video as well. I would say that most large businesses are better suited to AWS, Azure or Google. The platforms are just more mature and will provide the sort of services, configuration and security options that are expected of an enterprise infrastructure. The mid-tier providers are more like small business networks by comparison. They still have a place. There's no point building a cathedral if all you need is a garage, but you might outgrow them. If you want to move a business entirely to the cloud, then the smaller ones are really going to struggle because not supporting Windows or the paid enterprise Linux distributions is a major limitation. Where these smaller providers really shine is for smaller stuff like web hosting or personal projects. Most websites are hosted on a free Linux distro, so they'll be fine. The vast majority of people talking about using these seem to be looking for a low-cost option to host a website rather than the full business infrastructure, which says a lot about realistic use cases. That's not to say you can't run a larger infrastructure on them or that people aren't successfully doing it, it's just less common. If you're using it for a personal project, then you likely want to keep costs down and commitments low, and you don't want to worry about how much bandwidth you're using every time you connect to it. If you're building your own application, then choice is likely to be influenced by your chosen architecture. Is it using a serverless design? Does that tie you to a particular vendor? Did you deploy it in containers? How mature is a vendor's containerization and orchestration services? For the sort of stuff I do, I don't build websites. The typical use case is going to be business infrastructures. For me, that's mostly Windows. When it's Linux, it's likely to be an enterprise distro like Red Hat or SUSE. If it's a bespoke application, then our software guys seem to be really into serverless these days. So what public cloud looks like to me professionally is AWS or Azure. I need the enterprise toolset for my enterprise use case. If on the other hand I was moving a personal project up to the cloud, like the Nextcloud server I have at home that runs in CentOS, I'd almost certainly not use Azure or AWS. I don't need all the enterprise features for that, and if I can do the same thing just as well in Linode for a lower cost, then why pay more? I'm not making a solid recommendation for one vendor over another in this video. The goal was to compare types of cloud providers for you, rather than AWS versus Azure or Linode versus DigitalOcean. It's more providers like AWS versus providers like Linode. That said, I'll put links to all of the vendors I mentioned in the video description so you can have a play yourself. Most of them come with free credits if you sign up for a trial, but for some reason the amount of credit you get can in some cases depend on the link you follow, so I'll try to find the best ones for you to use and put them down there. If you have personal experience that you'd like to share about a particular vendor, then please go ahead and put it in the comments. I don't have the time to do enough testing for this video to be a really solid recommendation for a particular vendor, but maybe you guys can build a consensus in the comments section. I hope this was useful for you. Let me know if there are any follow-ups you'd like to see related to this video, but before you go, also have a look on this side of the screen and see if YouTube did a good enough job of guessing at what you'd like to watch next. If you found this useful, give it a like, consider subscribing if you haven't already done so. Thanks for watching guys, see you next time.